So, this is the questions that which I said you should do last time. So I'm going to start by writing those questions. So, first we're told to find a power series. We're told to find a power series representation. We're told to find a power series representation. So, we're told to find a power series representation, and they say for the following. For the following. Says for the following what? For the following function. And determine, and we must determine the radius of convergence. Right. Then for this question, then we're given g of x is equals to 1 over 1 minus x squared. You see, right? So now remember, I said that when we are doing this, we should try to familiarize this question with geometric series. Remember, hint, we know from geometric series we have that the default series as n is from 0 of x to the n will be equals to 1 over 1 minus x, such that this will be less than 1 for this to converge. You see right now? Such that converges when the absolute value of x is less than 1. We see, right? So now we say this now. We say that when we are given a question, we should try to familiarize it with this thing, because we are looking for this representation, right? And we're given a question, so we must try to familiarize it with that. So what you can do when it's in this manner, you can derive. So we want to drive this and see what you're going to get, right? So we can derive this. So let's see, can we derive? So you can do two things, right? You can derive this, or you can integrate this, as long as you know that it will take you to something like this. So let's check which one is correct, right? So let's say I decided to derive. There are some that you can see that this one is can take you time to get there, right? Or if you integrate, you'll get the right one, or if you derive, you get the right one. So I want to change this to this. You see, right? But in this case, I'll explain later. But let me just say, let's derive. If I derive this, I would use quotient rule. You agree, right now? I would keep the denominator. Derive that is 0. Now let's derive this. Realize something. When I derive this side and keep 1, I would get that this thing will increase. You see, right? It doesn't take me to this. It must decrease for me to go here. You see, right? So it means that deriving this function won't be the correct approach. So there are certain questions where you won't necessarily know if I'm going to derive or integrate, right? So it means that I can also integrate. I can say, if I integrate this, 1 over 1 minus x squared dx, if I integrate this, what do you think I can get? Anyone who can tell me how do we integrate this? Anyone who can tell us how do we integrate this? If I integrate this, what do you think we can get? So if we integrate this, we can say this. We can let u be equals to 1 minus x. Is that right? Then we derive this. This will be du equals to minus dx. Means that we'll have the integral of 1 over u minus du. So this will be minus integral of 1 over u du. I want to check if this is squared. So if we integrate this in this manner, we are going to get this. We're going to get minus u minus 2 plus 1 over minus 2 plus 1, right? So which means that this would be minus, let me substitute back my u is 1 minus x. This would be minus 1 over minus 1. Then minus 1 would cancel. That would have 1 minus x minus 1, and this is 1 over 1 minus x. You see, right? So I turn that to this, and I know that this one is a default series which is in this format. You see, right? Which is in this format. But don't forget, this is the series of the integral of g of x. And what you're looking for? We're looking for the one of g of x. So for us to get this g of x, we must now come and derive this. You don't forget if we want to undo integration, we must derive. So this will be equal to if we derive that, we get nx to the n minus 1. And then this would be the power series representation of this function. You see, right? Any question? Any question? So guys, here's what I was thinking, right? I realized that this topic, as it goes forward, it's gonna require us to know topics like this. It's gonna require us to know topics like integration in detail. Integration, this one we know already, integration. It's gonna require us to know functions of continuity. And then also drawing graphs and all that. So I was thinking that we move a cross-net session. What do you think? We should move a cross-net session. You see, during the cross-net session we cover everything, so that we can have enough time to do questions and revision. What do you think, guys? We can move a cross-net session. What do you think?
Yes.
We can do that, right? Do you agree? Any objections? Usually I take the people, if I discuss with you here, we don't even need the approval from the others in the group since they're not here, right? So we can do this.
When are we? When are we read? When are we read?
When are you guys writing? Now let me open a calendar now so I can check the dates. When are you guys writing?
16th.
16, eh?
On Wednesday.
Yeah, we can have
Which
it.
is Wednesday.
We can have it on Saturday. Saturday. You see that we have it on Saturday. Sunday we meet at 3 or 4. It's like we have a cross-net session and we still meet on Sunday, right? Then
now I'm writing chemistry on Monday. So cross-net Saturday is a little problem for me.
Oh, you cover right. When today no wala chemist, tomorrow no attack chemist, Robert. I'll be writing, but then yesterday I had a crossnet session with SMTH, and I'm writing also tomorrow. You see, we must multitask because the test that is coming next is Mori, so we must make sure. So make sure you can do this today or tonight. Make sure you spend like at least 4 hours studying that chemistry. Tomorrow you do the same thing 4 hours or more. Then after crossnet session, that can give you the enough time to study chemistry on Sunday. Or it means that when you can skip the Sunday class. If you're writing chemistry, you'll be allowed to skip the Sunday class. Then you can do chemistry also on Sunday. Then Monday, after chemistry, we see what do we do. Do we meet? We'll see if we did meet contact or what. But I think we can meet up until you write. Can meet. We meet on Saturday on your contact cross night. We meet on Sunday 4 p.m. We meet on Monday, I don't know time. We meet on Tuesday. So Wednesday you go right. We agree right. So it means that from Sunday, if we can move the Saturday cross night, from Sunday we'll just be doing questions. Sunday, Monday, Tuesday. So we'll have 3 days of doing questions. So
Yes.
yeah, so let me just send this there, and then before I forget. Yeah, if you didn't attend class, you'll be shocked because I'm just gonna write feedback, then I write what's gonna happen. So what time should our cross night start and end? It should start at what time and end at what time?
8 to 5.
8 to
5.
8 p.m.
Yeah, 8 p.m. to 5 a.m.
Another suggestion?
And 10 p.m. a.m.
10 p.m. to what?
3 a.m.
To 3 a.m.
Yeah.
Oh well. 3
No, what about those who live outside?
No, I agree with 10. Let's combine the two suggestions. One suggestion said it's 8 p.m. right till 5 a.m. Then the second suggestion said it's 10 p.m. till 3 a.m. So then my suggestion, which this one doesn't even need voting. I was just asking you guys what time should we start, but I knew already what time we're going to start, till 6 a.m. Now that one is mine. So we're going to start at 10 p.m. till 6 a.m. for the sake of those who stay off camp. And the reason why I say 10 p.m. ish, I need to rest a bit. You see, usually I need to rest. Then from 10 I can be active. You know, those who want to cook. Then if you stay off camp, you can just come early to campus. Yeah, relax on campus a bit. You wait for 10, or you start something else. Then you wait for us there to move the session. So we can do this. So topics that we're going to cover here, we're going to cover chapter it's chapter 2 until 4, right? 2. It's usually chapter 2 we've covered it, but we're not gonna start with infinite series. We've already covered that. We're gonna continue, right? Then when we still have time, we go back. Chapter 3, it's power series. So we'll continue with power series. Chapter 4, it's continuity of multiple variables. Yeah. So now infinite series, power series, what else? Continuity of multiple variables. And then Sunday we meet at what time should we meet at Sunday? On Sunday, man.
So,
Yes.
are you still teaching, or we're just discussing about the cross-matching session?
I'm teaching. I thought I was still checking in, then we continue. So on Sunday, what time should we meet?
Okay.
I'm trying to gather this so that I don't have to create. It's serious. Others are not here, right? So I want to send this information. I don't want to create posts there in the group because I know some will vote and still not come. So I believe that you guys here will come. That's I want your input. So Sunday we should meet at what time? Alright, since there's no reply, I'll take 4 p.m. till 6 p.m. Then Monday we'll discuss. Yeah, so I sent that information. Now let's go back here. Now, do we all understand this question which I wrote here? Remember, we're given g of x. We know that we should change this to this format, right? So you can do this in many ways. You can either integrate or derivate. So I showed you by derivating first and we realized that no man, this can work by derivating, right? Then I showed you also by integrating and said that then integration works. You see, right? So now we can say this. We can say another way to write it. We can say or. So we know that since we're given, since g of x is equal to 1 over 1 minus x squared, we know that this will be the same thing as having, this would imply that 1 over 1 minus x squared will be equal to the derivative of 1 over 1 minus x. You see, right? And then this would be, now we know this. We know that 1 over 1 minus x is the same as this. You see, right? X to the n. And then this would be, now we can derive that. I want to show all the steps. then this would be the summation infinity n is equals to 0 of n x to the n minus 1. Then this would be the power series representation. We say, right? So now we know that this happens, or this will converge for absolute value of x less than 1. You see, this x is no constant, so I'm just going to take it as it is. Absolute value of x less than 1. So it means that r will be equals to 1. You see, right? And they said we should find the radius of convergence. And this would imply that minus 1 will be less than this. You see, right now? And this is not the interval of convergence. This is the interval of validity. So for us to find the interval of convergence, we must take the endpoints and check if it converges from these endpoints. So we can say that if x is equal to minus 1, I'll go back to the original equation, or the original representation is this one. I plug minus 1 on that x. So it means that I'm going to have you see, right? So one thing we know about this is that this series will alternate. So this will converge, you will diverge by divergence test, or by alternating series. So this will diverge. So usually, yeah. So let me say, if I find the limit of this, I'd find that the limit is infinite. So I can say by divergence test. Divergence says you just take the limit. If it's not 0, then it diverges. So the limit of this is infinite. You see, right? So we say now if x is equal to 1, the summation n equals to 0 and 1 to the n minus 1. This would also diverge, because this would give us, would be left with n, and the limit of n is infinite. So this will diverge by divergence test. You see, right? Hence, the interval of convergence is minus 1 and 1. The open interval of minus 1 and 1, because it doesn't converge at these endpoints. If it converged at the endpoints, I was gonna say this. You see, right? So it doesn't. So I put open bracket. Any question? So if there's no question, we can move, right? So now we come to the second one. The second question said that we have h of x, which is equal to ln of 5 minus x. Right. So ln of 5 minus x. So if we have this, h of x is equal to ln of 5 minus x, now we know we should change this. Always I told you we should change this to this format. So obviously for this, you must ask yourself, am I going to derivate or integrate? You see, right? So what I can say is that we know that the integral of 1 over 5 minus x, you see, right, dx will be equal to minus ln of 5 minus x. But if I want this positive one, I can easily say I will get rid of this negative. Don't forget our thing there, our function is positive, so this negative will come here. You see, right? So every time you're given a ln function, you'll use integration. So the integral of that is equal to that. Every time you're given a function like this, we prefer that you use this method. You see, right? So, which is fine. And then, now we must find the representation for this. Then we integrate it to be equal to this. So, the representation for this one,
5 minus x.
yeah? You're saying what? So the
What
representation.
if it's 1 over ln of 5 minus x?
What if it's what?
1 over ln of something.
Oh, we'll come to that. Let's focus on this one now, and then you'll give me that question. No problem. We'll come to that one of 1 over something. That's fine. So now we still have this one, right? So remind me that one after here. So we have ln of this over here. So we're gonna say if we integrate this, we'll get ln of that. You see, right? And then now we say that if I have this ln of 1 over 5 minus x, I must change it to this. So first I know that this one must be 1. So I'll factor out 5 there on the denominator. Factor out 5, 1 minus x over 5. You see right now? And then this would be, now this would be minus, I can take out 1 over 5. Can just take 1 over 5 and then I put it out, right? I think it will be fine for that. So 1 over 5 integral of 1 over 1 minus x over 5 dx is equal to ln of 5 minus x. And we know that for this, since it's in this format, you see, right, it means that this will be the summation infinity n equals to 0. On x we plug this, x over 5 to the n. This is dx, which is equal to ln of 5 minus x. You see, right, this is minus 1 over 5 integral of this will be the integral of x to the n over 5 to the n dx is equal to ln of 5 minus x, and this would be minus 1 over 5, or this minus 1 over 5, I'll put it as minus 5 to the minus 1 times 5 to the minus n. Then summation, I just took out this one as a constant, right? N equals to 0. I integrate x to the n now. Then this will be minus 5 minus n minus 1 summation of infinity n equals to 0 of this would be integration of that would be x to the n plus 1 over n plus 1. You see, right? And this we know that this is equal to ln of 5 minus x. And this is equal to ln of 5 minus x. Right? So, now this can be written as minus, let me factor out negative there first, n plus 1. So I can take it to the denominator, right? summation of infinity n equals to 0, x to the n plus 1 over n plus 1. Then this would be minus 1 over 5 to the n plus 1. Summation n equals to 0, x to the n plus 1 over n plus 1. Ln of 5 minus x. You see, right? Then this would mean that now we can expand this. So this would mean that this would be, so I would have this one is, let me check, 1 over x to the this, 1 over 5 to the n plus this. Then we have, then we didn't leave anything right now. Let's confirm if we left anything or we left this outside. Let's did we use it? Let me check. Yeah, we used it. So you should always confirm, right, if you leave anything outside. So that time I had taken this outside, but then I kept it all along. So I'm glad we did that, the caption. So we kept it. This one means that now it must come inside. You see, right? And then this will be the summation infinity n equals to 0 of, this will be 1 over, then this would be 5 to the n plus 1 is minus, and this is x to the n plus 1 times n plus 1. So ln of minus x. Yeah. So any question? So the only thing that would have here, so this would be the integral of this, right? So let me check something. Where did we start integrating here, right? So some books prefer this, guys. Some books prefer that, after integrating you must add plus c, right? Some books prefer that you add plus c plus c plus c. Then the question is, how do you find the c? You see that? So for the time being, as we can just be staying away from the c. I'll just write it as read here, so you can see. If you find somewhere, maybe you are finding other books, they write plus c, you should know where it's coming from. It's coming from the integration. So let me try to scan this question and see from photomath, do we get the plus c or not? So let me see. Yeah, we do get the plus c also from here. So it means that we're gonna take this plus c. So we all know where is this plus c coming from, right? So don't be shocked when you come across such questions. You have that plus c. So this plus c is coming from this integration. Then now we need to find what is c. So the question is, how do we find c? Anyone who can tell us? What is a constant? What is the derivative of a constant? Guys, what is the derivative of a constant? Derivative of a constant?
It's a constant.
It's a constant, right? So it means that for us to find the c, we can let x, the derivative of a constant is a constant. Yeah? Hello?
Yes.
0.
It's 0. It's 0. Don't say a constant. 5 is a constant. So the derivative of a constant can be 5. The derivative of a 7 can be 5. So it's 0, right? So we must let x be equal to 0. Then we find c. That means that this will be, if I plug a 0 here, plus c, this will be equal to ln 5 minus 0, should imply that c is equal to ln of 5. You see right now? So it means that this will imply that minus the infinity of minus this n equals to 0 of x to the n plus 1 all over 5 to the n plus 1 times n plus 1 plus ln 5 is equals to ln of 5 minus x. We agree there right now. So now we see that now this would be our power series representation. So this plus ln 5 is not part of this summation, right? It's just there, we just added it. So that is the power series representation. So such case is possible. We're going to do more questions that are based on this, that we can find such series to be like this. So now the question is, what is our R here? Who can tell me what is our R? What is our R? How do you think we can find our R? Anyone who can tell me what is our R? Guys? Guys, our R? Or let me give you 3 minutes. Can we find the R here? I want to see something. Try to find the R from this series. Let's try to find R. You have 3 minutes. I want to see something. There are many ways you can find R, so find it anyhow. Then I'll show you the easiest one. Three minutes. If any has found the solution, can say it, guys. Right. Answer. Answer, guys.
Yeah, so what if we use the root test?
Hey, it's also fine. I mean, I just want an answer.
Fine, I got 5.
5. Nick, can you send the computations in the group? Another one? Alright, we'll go with the one of 5 since everyone is quiet. Let's see. So for finding the radius, we can simplify this further and say that this will be n equals to 0. This will be x over 5 to the n plus 1. 1 over n plus 1. You see what I did there right now? Less than 5. Then this would imply that if you check the series will converge for absolute value of x 5 less than 1. You see, right? This would imply that the absolute value of x will be less than 5. We see how we got the 5 right now. You can also use root test. It's fine. You can also take the long route and use root test. So, any question? Any question? Alright, if there's no question, it means that now we see right now. So, now I want to check if it converges or diverges at those endpoints. So the endpoints are, now we're going to check if it converges at -5 and if it converges at 5. So now let's check. So we say if x is equal to -5, then we go back to this series and we plug -5 where there's x, so that the summation minus the summation of that of -5 over 5, the n plus 1 plus ln 5. Then this would be, now if we check, this is minus the summation of infinity n equals to 0 minus 1 n plus 1 over n plus 1 plus ln 5. So now here I can use any test to prove this. If I use this test, if I use a divergence test, if I just come and use divergence test, let me see, we can use alternating series. First, if I use alternating series, I'll find the limit of this, right? I find that it's 0 for that one. If I add it with this, it won't be 0 anymore. We see right now. Do you agree on this? We say that the limit won't be 0 anymore if I use it with that. Then, now, let me see, I think this we're going to say the limit. We can use any test, but I think the best one, let me check, the best one would be, let me just use the divergence test. So here the only problem you have to check is which test can I use, and find out that most tests work right for this. So it means that we can apply divergence test for this one, right? So we can say by divergence test, with the so we apply divergence test. Okay, let's try to apply divergence test and see what we get. So if I apply the limit of this, we get, then we have plus 5, and we would get the limit for this one. We get the limit of this. We get let me see, this one minus 1 plus 1 will revolve. I think this one will revolve around minus 1 and 1, if I'm not mistaken, this one. So I'll just, yeah, it's correct. Let me prove it. We can have this, and approaches infinity 1 over n plus 1 times the limit. Yeah, it will revolve around minus 1 and 1, because we see this one is an alternating series. So since this revolves around minus 1 and 1, we see that it diverges, because when it should converge, it should converge to a certain limit. The limit should be unique. So this will be 0 times this one. This one will revolve around minus 1 and 1. You see, right? So it means that every number that we get here, we multiply it by 0. So we'd get that. And then if we use another method, I think another method that we can use, but the only problem that we get here, let's say we get that this is 0, right, times anything that we get here. Don't forget we have this plus ln 5. So I would take that and add my ln 5. You see, right? So you see that this one no longer becomes 0, the divergence test. So if it's not 0, it will diverge. So I believe that this is going to diverge. So from minus 5, it will diverge. So usually we don't deal with such I don't think have you ever came across a question that the limit, the certain limit, or a certain function that is outside the what's this, outside the summation? Have you ever came across such a question? No, right? But it's possible. You see, right? So it's possible So now we're also going to be forced to choose add a limit or any test that will allow us to add this at the end. You see, right? So can be any test that will allow us to add that at the end. Let's check if x is 5. If x is 5, this is going to be 1, 1, and this would be 1. We're left with 1 over n. If we find the limit of this, we find that this alone would converge. And then we add that plus ln 5. So means that I would be correct to say this. So let me erase this. So I would be correct. It stopped here, right? This pen is off now. Let me try to do this. Yes. I think I have to unplug this thing, then I charge the pen because yeah. So let's check here. So we should check determine the function and determine the radius of convergence. Yeah, so our radius of convergence, we said that it's 5, right? Radius of convergence is 5. So that the radius of convergence r is equal to 5. Then we say that for the interval of convergence, even though we're not asked to check this, right? So most of the times they might not ask you to check this, because we see that for this limit, if I try to check if it's convergent or divergent, we can only check this. We can't check this because this is not a series. You say, right? So we can only check this. So I don't think they can ask you to say interval of convergence. But the radius of convergence would be 5. So now let's come to these questions that we can come across that I can say you must try. Remember last time I said that you should try these, right? First, let's try if we are given f of x is equal to 6 over 1 plus 7x to the 4. Obviously, we know that if we are given this, let me start by giving you a heads up on this one, right? If we know that if I'm given f of x is equal to 6 over 1 plus 7 x to the 4, you see, right? First, I can drop 6. 1 over 1 plus 7x to the 4. You see, right? Secondly, I need to change this to negative. 1 over 1 minus 7 x to the 4. You see, right? Then now I know that this will be equals to, I can write the 6 here. The inside will be the summation of n equals to 0. Where there's x, we plug minus 7x to the 4 or to the n here. You see now, right now? Then that is the power series representation that we have from this one. Then now the first question is, what is the radius of convergence? You see, right? So we know that for the radius of convergence, we say that will converge, this series will converge if or for, I take the absolute value of this x, that is represents our x value, less than 1, which this would imply that x to the 4 is less than 7. You see, right? Then here would fourth root both sides. You see, right? Then what is the radius of convergence? Anyone who can tell me what is the radius of convergence here? Oh, if I divide both sides by 7, this one will be 1 over 7. This one will be 1 over 7. And this will imply that absolute value of x will be less than 1 over fourth root of 7. Then here, our r would be 1 over fourth root of 7. You see, right? Now we see. Any question? Any question? Any question? Any question? So if there's no question, now find the interval of convergence from here. You see, right? You see that this question was this simple, right? Now let's do another one. Then we see. Usually I wanted to give you these questions to do, but it's like, let me just do some. Now, let's say we have this one. We are given that f of x is equal to x to the third all over 3 minus x squared. Remember this, I can just drop x to the third. 1 over 3 minus x squared. Then I must change that 3 to 1. We see right now 1 over 3, 1 minus x squared over 3. You see, right? And this would be 1 over 3x squared, your x to the third, 1 over 1 minus x squared over 3. And this would be x cubed over 3 summation n equals to 0 minus, not minus, of x squared over 3 to the n. You see, right? Then this would be, now we say the summation, then this would be x 2n over 3n times x3 over 3, 1. Then this would be equal to the summation n equals to 0, 2n plus 3 all over 3n plus 1. Any question? Any question from here? So now we can simplify this. There's no question. First, to find that radius of convergence. And this can be Yeah, so we can just leave it like this, it's fine. Then we know that the radius of convergence, we say that it will converge for less than 1, and this will imply that we're going to have the absolute value of x squared less than 3. So this will imply that we're going to have the value of x less than root of 3. So this will be the case. N-equation. Then radius of convergence. Then we say find interval of convergence. So can we pass from here? We can, right? So I think I've given you enough problems to look at. So now we come to Taylor series. We come to Taylor series. We come to Taylor series now. So is there any question based on the previous ones before we can move to Taylor series? Anyone? Any question? Any question? So now the question is, what do we do on Taylor series? Anyone who can tell me, what do we do on Taylor series? What do we do on Taylor series? So what I can say is this, right? On Taylor series, we can define it that if we're given f of x is equal to the summation infinity n equals to 0, we have f to the n of a all over n factorial times x minus a to the n. This will be f of a plus f prime of a x minus a. And then we're going to have plus f second prime of a, let me say, over 2 factorial times x minus a squared. Then here say 0 factorial 1 factorial. Check something. This is fa 0 prime. You see, right, your 0 factorial on the denominator. In other words here, if we come to this one, the second one, we have first derivative 1 here, 1 here. You see, right? So this one, the first one has fa x minus a to the exponent 0 over 0 factorial. That's why this one is not there. You see, right? So the formula is just like this. You see, right now. And then when we come to f1, x minus 1 factorial, we come to f2. So some of you see them writing like this: f2 of a x minus a 2 factorial, f3 x minus a 3 factorial. You see, right now. f4 a x minus a to the 4 factorial. You see, right now. f5 x minus a to the 5 factorial. You see right now? So this is that pattern. So there's nothing much to this. It's not like we are coming across something new. Just us combining these functions and so on. So now let's apply this. It means that when you come to 3, so it will be like this, of a x minus a to the 3 vector. You see right now? So now we have this. Now this will be the format of our Taylor series. You see right now? So this will be the format of Taylor series. So now let's say we come to these different types of Taylor series. Let's say we suppose we say that if a is equals to 0, then this would mean that we're talking about Taylor series about x equals to 0. You see right? And this is called what? This is called Maclaurin series. And I just come here and substitute. Where does a substitute 0? Now let's see. This would be f of x would be equals to the summation of infinity n equals to 0. This would be f to the n. Where does a substitute 0? You see right now? All over n factorial. And then I'll have x minus 0 to the n. This is what? X to the n. That would be our Maclaurin series. So now that is it. So now we know what is Taylor series. We know what is Maclaurin series, right? So is there any question that I can get before we try to compute? Any question that we can get? Any question? Before we can try to do some examples of this Taylor series. Any question?
Sir,
Yes?
based on Taylor series, we need to know that formula and able to apply it.
Yes. We need to be able to know the formula and be able to apply it. So
Then
now, Maclaurin said what?
Maclaurin series goes with Taylor series.
Yeah, it goes. It's just a special case of Taylor series. That's why I said that if we let a be equals to 0, this will be a Taylor series about 0, means about the origin.
Oh, okay.
Yeah. So now let's come to, based on that, we'll talk about other things. There are things which you can look at. We can look at the nth degree of polynomial degrees. Of polynomials, and also we can look at the remainders. So did they teach you guys about the remainder? Did they teach you?
Yes.
They did, right? So for us, okay, let me just define this, right? So we have what we call the nth degree. It's called the nth degree Taylor polynomials. So of f of x. So this is given as Tnx, which is equal to the summation of n. Okay, let me answer the question. Yeah, so we can have, this can be I equals 0, then we have f of I, then we're going to have our a over I factorial, then we have our x minus a I. So check something. For the nth degree Taylor polynomial of f of x, we just come to Taylor series. We replace n. We see where we see n here. We replace that n by I. You see, right? I. Then we'll apply it. Now we just write the formula like that. So I'll check how they write it on your guide, right? How did they write it on your guide? Anyone who has video or your slides, how did they write this series on your slide? Did they write it like this, or how did they write it? Those who attended, or you have done this, you have written the notes. How did they write this one of Taylor polynomials of f of x? How did they denote it? Because they can denote it anyhow. Someone can decide to use j here, some can use the k. You can use anything. It's up to you. So we're using I. We can use anything. It's up to us what to use. So there's no real was this a constant summation to that? So yeah. So if they've used anything, is fine. So now we come to a remainder, right? Now this is the formula that we're gonna use for the Taylor polynomial. Then for the remainder, so for the application, I'm just gonna write these formulas, and then for the application we'll start by Taylor series. We come to Maclaurin, then we come to this nth degree Taylor polynomial. Then for the remainder, when we come to the remainder, we're saying that our formula for the remainder will be, this will be equals to f of x minus that degree of the polynomial. You see, right? Then this will be the remainder. Now we know that now if we take this, it means that if we are looking for, let's say sometimes they can give you the remainder, they give you that this one of the polynomial, the nth degree of the polynomial. Then they say find the function. You could find the function by just taking this to the other side. You see, right? So that will be simple. So is there any question here before we can apply application? So let me do write application, and we start with the one which is the most common one. So the first thing which they can say, they say find the Taylor series of f of x is equals to e to the x about x equals to 0. You see, right? Then they give us this. So it means that we know that our f of n x is equals to e to the x, given that n is equals to 0, 1, 2, 3, and so on. You see, right? So here they say that this is about what? 0. So does this mean that you are going to, you see here they say what? Find Taylor series of f of x is equals to e to the x about x equals to 0. So what are you going to do? Anyone who can tell us which formula we're going to use for this about x equals to 0? Anyone? Anyone? What are we going to do about x equals to 0? About x.
So what is your question again?
I'm saying that they're saying that find the Taylor series of f of x equals to e to the x about x equals to 0. So what is the first thing that comes to your mind? They're talking about Taylor series. What is it that you're going to do? Or let me erase this. I think I wrote this here. This is not that important to write. What are we going to do? The question comes like this, where they're saying they want Taylor series. What do you think we can do? So, what I can say is this right now. They say they want Taylor series about x equals to 0. So, what I can say is this, is that we can do this. We can say that according to the formula, we have that f of x is equals to the summation of that, all that. So also we know that this is equals to f of a over 0 factorial. We say right now plus f of 1 then a x that. So what we need to do here is that we need to derive, right? So this is the summation. Let me just summarize this. We need to derive this. If they didn't specify anything about x equals to 0, we're going to do this for this one. We're going to say this. We say that this is n starting from 0, and then we have x. If I derive this, what do I get for the first time? I get e to the x. This one is the first one, right? I don't have to derive the first one. I keep it as it is. So this will be the default one, the first one. Then if I derive it, I'm going to say this f1 x is equals to, it remains the same. We agree right now. I derive it again, it remains the same. So remember the formula says this. The formula says that this will be, it says that f of x is equal to summation. Let me just write the formula. N equals to 0. And then let's say this says that we're going to have f of n of a over n factorial of x minus a to the n. So when they say x is equal to 0, so okay, before I talk about x equals to 0, let's come here. This would be f of n a 0 factorial plus f of 1 n a 1 factorial. You see, right? If we come back here, I was gonna multiply here by, I don't have space here, so let me just copy that one, x minus a to the 1. Let me just copy that one, then plus, I would put you like that. Just copy this one and make it small. So just copy this, then I explain this. So yeah, let me do this here. So now this would mean that we know that our f of x is e to the x. You see right now? So now for this one, we need to derive one by one. We need to find this term. We find this term. We find this term. We find this term. And they're saying that at x equals to 0. You see right now? And we know that from the beginning, x is equals to a. This will converge for this met. So it means that here we don't have this x minus a. This is about the origin. You see right now? So we don't have that x minus a, which is the it could be it could be like the Maclaurin series in this case. You see right? It's x to the n. So what you're going to do is this. You take this, you derive. The first one, you see this is f to the 0 is this first term. Just that they didn't write here that this is 0. You see right? Then the second one is f to the 1x is this one. You see right? But here we have that x is 0. And then we have f2 this one. Then it's this one, f2. You see right? So when we derive this, it remains the same. If I derive e to the x remains the same, I derive e to the x remain the same. Do you agree with that right now? So I can derive e to the x multiple times and it remains the same. We agree on that one right now. I can drive, it remains the same, drive, it remains the same, drive, remain the same. So even if I was given this, if I was given f of x is equals to minus, not minus, it's equals to e to the minus x. First thing that you need to do is you can derive. You see right now, the first thing I have to write it as it is. F of 0 is the same. Then I derive, I get minus this. I derive on 2, I get this time this e minus x. Then if I derive again, I get minus e this. So the first thing that you need to keep in your mind is that on Taylor series we're going to derive. We derive, and so on. We agree right now? So that's the first thing that we're gonna be doing. So I don't know if I have those notes here. Let me check if I have those chapter 2 notes here. If someone is knocking, I'm coming. So now it means that I can't find those notes here right now. Yeah. Is this one? So remember, first thing that you're gonna be doing is first we keep it as it is. That's our first function. We derive, and so on. You see right now. So some functions, they remain the same. That's why for this one, for e to the x, it has a default power series representation for the Taylor series. You see right now. So it has the Taylor series representation that is default. So let me erase this. And then now we get to the solution. So don't be shocked when you come across questions that we're gonna derive. You should know we must derive most of these questions for the Taylor. So I've specified this. So I'll put this one here. So now let's answer this one and see how we're going to answer it. One close there. Yeah, so first I can write this. This is a function. I can write that here I have f of, it can be f of, can write it as f of n x is equals to e to the x. I'm copying this formula. Now I'm trying to generate this formula. You see, right? Our a in this case is equals to x. So I copy this formula. So I have this now. You see, right now? Then I can try to compute that. Remember, I want to compute this only. This top only. You see, right? So I know that from this I can generate, always our n starts from 0. We know that, right? So it means that I can generate, I have that where n is 0 of x, I copy that the original one. You see right now? Then I say that where n is 1 of x, if I derive this, now I'm deriving that, it will remain the same. You see, right? Then if I say f of 2x, this would be remaining the same. F of 3x, this would remain the same. So I would go back to the power series and say this is f of x is equals to the summation, or instead of the summation, let me start here before I start with the summation. So this would be equals to, now here I would have f of a is the first one, it's e to the x over 0 factorial, plus the second one, it's e to the x also, e to the x, don't forget this one x there, x minus 0, for that one here I have 1 factorial. You see, right? And then this one I have plus, then I'm going to have This one is second prime, right? So I'm gonna write this ones only. I'm gonna write this. I write this first. I write this only. This will be e x over 2 factorial plus e x over 3 factorial plus and so on. You see right now? So this would move, don't forget this one, it would move up until infinity. I'm sure we agree for that. And then this would be, if I have this, I can remember this, they say that this is the Taylor series about the original, about x equals to 0, right? And f of x is what? Is e to the x. So f of x would be equal to, this can be the summation of infinity n equals to 0. So if I look at this, I can try, or maybe I can start by doing this. I can do this. I can have e to the x here. Inside I'll have 1 over 0 factorial plus 1 over 1 factorial plus 1 over 1 times 2 plus, or instead of 1 times 2, let me just keep it as 2 factorial plus 1 over 3 factorial plus and so on. This inside, if I keep it as a summation, if I keep this inside as a summation, this would be 1 over n factorial. If I was gonna put it inside this, if I was gonna put it inside what's this, inside the summation, you see right now. And our variable of interest here on this one is x. That's why if you come back and you're gonna have this, if you come back and say, let me erase this. For this one we understand, now we understand where the 1 over n factorial is coming from, right? From this, we understand where the 1 over factorial is coming from. So it means that on this one we can have, so we can do this one from this method, and then we'll also check the one on the guide. Or how do they do that one on the guide? So now that this one would be the summation until infinity of n equals to 0. Then there we have 1 over n factorial. And we know from the default, what's this, the default geometric series 1, we have that x to the n. You see, right? So this one is coming from this factorial. And this one is default because it doesn't change when we derive them. You see, right? Then this would be the summation of infinity n equals to 0 of x to the n over n factorial. Then this one would be the Taylor for the e to the x about 0. So let me check on that one, on how can we on how do they do that one. Let me see, it's chapter power series, right? I'm sure they did include an example like this here that we can look at. Yeah, they included an example like this. I'm gonna share it now, ne? So you see that is the same thing. So we'll do that. The nice thing that they did here is that they showed the computation. So here's what they did here. Let me write this one. Yeah, we'll see. So we copied this. We have this, but it's fine. Let me just write it here. So same computation on the guide, right? What they said that if we want to find the first 6 terms of the Maclaurin series, here they just called it the Maclaurin series, right? But you should know that it's a Taylor series where x is equal to 0, right? They said that A said f of x is equals to e to the x. And then first thing is to have f of x being equals to e to the x. Then if we plug 0, don't forget you were saying that x is equals to 0, right? For x equals to 0. So we plug 0 here, which is e to the 0, which is equals to 1, right? Then we derive this now. It remains the same, right? Then we say that f prime of 0 is equals to e to the 0, which is equals to 1. We derive again, it remains the same, which is e to the x, then second prime of 0 is equals to e to the 0, which is 1. We say right, up until we would move up until n. You see right, this would remain the same. F of n 0 would be equals to e to the 0, which is equals to 1. Now we can write our f of x as equals to f of 0 plus, we take these ones, right? F of 0 plus f of prime 0 1 factorial plus f of 2 0 2 factorial x squared plus f of 3 0 3 factorial x to the third, and then plus up until, you see right, and this will be equals to f of 0 is 1 plus that one is 1 also, so this will be x over 1 plus this is x squared over 2 factorial, let me just divide like this, then this is x to the third over 3 factorial plus, and this would be equals to the summation up until infinity n equals to 0. Then this x, this is from x0, x1, x2, x3 up until the n, which is, that is xn. This one is 0 factorial, 1 factorial, 2 factorial, 3 factorial up until the end. This would be n factorial. You see right? So we can also use this second method. But the one which is more structured is this one, because this one already you are giving them the solution. Then this one here, when I was breaking them one by one, I was trying to associate how do we get this from this. You see right? So we get that. So when they say now, let's come to a second example. Let me see if we can have a second example. But it's fine. Let's have this one of f of x equals to e to the minus x, right? And then now we have this one of e to the minus x, then they say at or about x equals to minus 4. This one is not from the origin. You see right? And then the original formula says that f of x or f of nx, yeah, f of x is equals to f of n a all over n factorial of x minus a to the n. You see right? So we can start by finding these ones. We can first say, we know that f of 0 a would be equals to the original one, and then we plug 4 there on a, minus 4. This is equals to e to the minus 4, which is equals to e to the 4. Then we come to the second one, 1a. So this one, you see this bracket I'm writing here, f1 is the same thing as having f prime of that, you see right now, which is equals to, or since you are dealing with f of x, don't forget a is equals to x, so you can just replace this by x. You see, right? You can just replace that by x. If I derive that, I'll get minus a to the minus x. Then I have now of 1 minus 4 equals to minus a minus minus 4, which is equals to minus a to the 4. Then I come and do the second one. And this one I know. Here's the second. You see, right? Then let's check this. And then now we can do the same thing. We say f of x is equal to, just like here. Now we put them under this whole scenario, right? And we say the whole equation. Say that f of x is equal to, we start with the first one. We got a to the 4. Then plus, let me write it down here. Plus, so don't forget this is over 0 factorial. And according to the formula, let's go back to the formula. You'll see. According to the formula, the first term doesn't go with this thing. You see right now. So there's no need for us to put that. It goes on the second one. And then the second one is minus. The first one was positive e to the 4. The second one is minus e to the 4. So I'm gonna put a minus there. The third one is positive e to the 4. No, I forgot here. Here it's x minus minus 4, which is plus 4. X plus 4 squared plus, no, this one is minus, you see, right? And this would be the summation until infinity of n equals to 0. And then we realize, yes.
Can we please scroll up? Oh, wait.
Alright.
Oh, I wanted to see if the first derivative. We could see when we substitute to what did we get?
Oh yeah, here's it. Alright. So we realize that this one is alternating plus, minus, plus. Is that right now? So first on our equation, we're going to have minus 1 to the n. And we check the first one. Is the first one positive or negative? It's positive. If I plug 0 here, this will become positive. So this is fine, having minus 1 to the n. Then I realize that e to the 4 remains the same. I have e to the 4. Then I check the denominator. It's 0 factorial 1, 2, 3. So this will be n factorial. Then I check this one is x plus 4. Then the exponents increase by 1. 1, 2, 3. So it's n. You see, right? So this will be the formula for this one. For e to the minus x. So this is the Taylor formula. So yeah, here's what's gonna happen, right? For this Taylor series, we're gonna start it from the beginning on Saturday. So we're gonna start with the whole of power series and finish it. So let me check, because I don't think I was able to explain this well here on the recording, because this thing limits me. So I think we'll need the board for us to explain all this. So we'll follow through, at least do 10 examples. I think if we can do 10 exercises, examples, we can see what's happening, then we can follow up. Let me